Ready?
Calculations.
Calculations. Calculations. Please give me your main points out, because I want to pass through this thing and we'll close it. We'll start another chapter. Because once I leave this, I will not touch those parts unless otherwise someone is talking of balancing.
Teacher.
Yes.
There's this part in solubility. I understood how to find solubility, but that's why they say they change the temperatures and.
That is still solubility. We are going to go back there because I've heard that is the main complaint there. The rest we can do. Yes?
Yes, we can do.
Yes, teacher.
It's okay. I've accepted. So the main problem is solubility. Someone differentiate for me a difference between strong and weak acid. An example.
Me.
Yes.
A weak acid is a solution that partially ionizes when dissolved in water, and a strong acid is an acid that completely ionizes when dissolved in water. An example of a weak acid, we have methanoic acid, and a strong acid, we have nitric acid.
Thank you very much. Someone to give us the best definition of the two. Someone to give us the best definition. She has given us what the description, but give us the best definition. There is no one.
Try.
Yeah, not trial. You must say it now because you are not trying. We know them.
A strong acid is an acid formed by strong metals.
By strong metals.
Yes.
Then the weak one.
Let me first change my statement.
Okay.
A strong acid is an acid formed by strong reactive elements. While a weak acid is an acid formed by these less reactive elements.
Least reactive elements. Now,
yes,
I will see the problem is still with those definitions. Yes, Patricia. Patricia?
A strong acid is one in which there is a complete ionization and
Thank you very much. Yes. It is reversible.
No, it's one in which there is a for a week. No, it's not. It stops ionization, and then a weak one, incomplete ionization, and it's reversible.
Okay, thank you very much. So when you look at acids, we said acid is a compound formed when dissolved in water produces hydrogen as the only positively charged ion. And the definition remains a definition. If you don't give us the ion that is present as hydrogen as the only positively charged ion, then the definition ceases not to be there. So take note of those words, define them now, because in the next 40 minutes, we are going to look at what you have complained of here. For now, let's do this and finish. Here they are saying an acid here acid, the definition is a substance when dissolved in water, you dissolve in water, produces hydrogen as the only positively charged ion. Positively charged ion. Anything that you dissolve in water and gives hydrogen as a positively charged ion, that is the acid. Now there are two types of acids. We have the weak one and the strong one. So if you have the strength of an acid here, is basically the strong one and the weak one. So the weak acid, a strong acid, is an acid that dissociates. It dissociates completely into ions when dissolved in water. It ionizes. If you don't want to use dissociates, use it ionizes in water completely. An example is sulfuric acid. Strong acid, sulfuric acid. This is the way you write sulfuric acid. Now, when it goes into water, it will give you hydrogen ions and sulfate ions. Those are the only two ions present in that acid. When you talk of hydrochloric acid, it also dissociates in water to give hydrogen ions and the chloride ion. It has dissociated completely into different ions. It has ionized, it turns into ions. These are the ions, what they are meaning ionized, it turns into ions, hydrogen ions and sulfate ions. This is a radical, this is an ion. So here they are saying this nitric acid also undergoes the same thing. It goes into hydrogen ions and the nitrate ion. Those are the only ions present. If they go into water, that aqueous state, that's what you form. Now, here, hydrogen ions, the number of hydrogen ions produced by the acid gives us the definition of the word basicity of an acid. The number of hydrogen ions, basicity, is the number of hydrogen ions produced by 1 mole of an acid. If 1 mole of sulfuric acid, let's say sulfuric acid has 1 mole, just 1 mole of this, the way you see it here. When it dissociates into water, it gives us 2 hydrogen ions and then the sulfate ion. This is aqueous, this is aqueous. Now, the number of hydrogen ions produced by this acid gives us the definition of the word basicity. So basicity, the number of hydrogen ions that can be produced when 1 mole of the acid ionizes in water. So the basicity of this acid is 2. That is the word basicity. So we have monobasic acids. Those ones ionize in water to produce 1 hydrogen because of the word mono. Di is 2 hydrogen ions. Tri is 3 hydrogen ions. An example is this. Phosphoric acid is a weak acid. So when it ionizes in water, it ionizes partially, but it gives 3 hydrogen ions. So the basicity of this acid is 3. So that is what we have as per now. So here they are telling us that there are basically 2 types of acids. That is, if you define it according to strength, you get strong and weak. If you look at the types, there are only 2. We have mineral and organic. Mineral acids, they are called mineral because they are derived from minerals. Examples is these common lab acids like sulfuric acid, hydrochloric acid, nitric acid. They are derived from the common minerals we have on Earth. Then organic, they are derived from organic compounds. Organic compounds, those in the senior 3, we now know organic compounds. But senior 2s, we shall also know very soon. So organic compounds, and they include ethanoic acid from vines, citric acid, you get it from fruits. An example of a fruit?
Orange.
Oranges. Actually, mangoes. That is the only way you know that. Then a raw mango gives you that acid, citric acid. When you take it, the way that mango tastes is the way that that's the taste of that acid. And the lactic acid found in the milk. Those are some of the organic acids. So properties of the acids, they have a sharp sour taste. That one we have known. When you take a raw mango, you take it like that. Acid change color of indicators. An example, it turns glutinous paper red. And then indicator like phenolphthalein turns it from colorless to from pink to colorless, isn't it? Actually, when you use phenolphthalein indicator, you will not see an observable change, but methyl orange turns from orange to red. So acids ionize in water to produce hydrogen ions. That one we have seen. Sulfuric acid, you get that. The number of hydrogen ions it produces when it ionizes defines basicity. Acids are more corrosive. They cause burning effect, both to humans and anything it comes into contact with. And it's very poisonous. Dilute acids react with metals to produce hydrogen gas and a salt. We saw how that one happens. Preparation of some salts, those most reactive salts, those between calcium and which one? We saw preparation of salts, the ones you use an acid and a complete metal. Not those ones that a metal can, that acid cannot, these metals that cannot displace hydrogen from the acid. So we looked at aluminium. We went to what? Which other metal?
Potassium.
No.
Okay.
It is between calcium and we looked at those metals. Look at your reactivity series. Reactivity series. How do you write a reactivity series? Now here is calcium. Metals between calcium and this lead here. They must be higher than lead, but lower than calcium. So we have magnesium, we have aluminum, zinc, iron. Those are the only metals that can react with the acids. And they have the ability to displace hydrogen from the acid. The rest do not. We looked at them from our table. All these, copper, mercury, silver, gold cannot displace this. Lead can only react with the concentrated hydrochloric acid, not sulfuric acid. The reason is it forms an insoluble salt, that's lead sulfate. And this lead sulfate ceases to stop any further reaction. So you can't use, it cannot react with sulfuric acid. You are reacting maybe if it is forming a sulfate of the salt. So here, copper cannot displace hydrogen. Mercury cannot displace, unless these ones have anything on them, like copper oxide. Now this one, the acid, the hydrogen of the acid, that's something it can get from the copper. But if it is a copper metal plus sulfuric acid, this equation has no reaction. No reaction. Because copper cannot displace hydrogen from this reaction. To take away the sulfate, it can never happen. So, what of potassium and sodium? They can, but their salts are always soluble, and most of them, so you can't. Let's look at them here. They are saying dilute acids react with the reactive metals to produce hydrogen gas and a salt. An example of sodium and potassium, that one is possible. But now this one is an aqueous solution. The only gas you can get is this. So they do react. But when you are forming salts, we looked at examples that you can only form salts in between these. Those are the only metals that can displace hydrogen from the acid. Am I clear? Yes?
Hold on, teacher.
Am I clear?
No.
No. This is what haven't you got? Yes?
The last part of your statement.
The last statement. They are saying here that dilute acid react with the reactive metals to produce hydrogen gas and the salt. Somebody was asking, what about potassium and sodium? All of them, they are reactive than the acid. So they take away what the acid has, the sulfate, the negative ion. The metal takes the negative ion and then you produce hydrogen gas. That is all. But now there are metals below the reactivity series. You see where hydrogen is? Any metal below hydrogen can never displace hydrogen from any reaction. That's why I gave you an example of copper metal reacting with sulfuric acid. This copper is alone. It is a metal. It can never displace or remove hydrogen and takes away the sulfate. So this one ends up with no reaction. But if copper has an oxide on it, at least the hydrogen has something to get from copper. The reaction will be possible. Is it fine?
Yes.
Okay. So here the end product is copper sulfate plus water. So when you are making your reactions, or if they give you an equation, study the equation before you answer. If a metal cannot displace the other metal from any reaction, then it will not stop. An example is also copper. If you're adding it to maybe magnesium sulfate, copper is below magnesium. Down, you see where copper is? It is here. Magnesium is far up this side. Therefore, this equation will not be possible. This one will be no reaction. But if copper has something that magnesium can take, then the reaction will happen. So maybe like that. If you have maybe copper 2 hydroxide, that one will work. So that is what is there. Now they are saying acids react with the carbonates and hydrogen carbonates to liberate carbon dioxide gas. When an acid reacts with the carbonate, a salt is formed, water, and carbon dioxide. All these. So if the acid reacts with any carbonate, you get salt, water, and the carbon dioxide. Now, an example is copper carbonate. Let's take an example of copper carbonate. This one is plus any acid, maybe hydrochloric acid. This is copper carbonate, solid, and this one is aqueous. We told you acids do not react when they are concentrated, but if you add some element of water in it, it becomes aqueous. Now the ions are free and they can exchange with this solid. So what happens is hydrogen has something it can take from this. So it becomes, it turns, actually what happens is copper gets the chloride. It becomes copper chloride. How do you write copper chloride? Shelly, how do you write copper chloride? Now people are quiet. Lynette? Lynette? Copper chloride. How do you write copper chloride? Elizabeth, that whatever is wrong. What you have written is wrong. Copper chloride. Vanita, copper chloride. when you are forming a compound called copper chloride, you must write ion exchange or radical exchange. Not a radical, but the power exchange. Copper has valency 2. A chloride has which valency? Yes? So when
-1.
yes, so when you're writing this, they exchange the powers. So where does the 2 go?
On chloride.
So that is what happens. You are writing copper chloride. Since it is a soluble salt, it is aqueous. Okay, Vanita, thank you. So we said when an acid reacts with a carbonate, you get a salt. What is another element formed? Water and what? Carbon dioxide gas.
Excuse me, teacher.
You excuse.
Teacher, you talked about a dilute acid. Can a concentrated acid react with an element like copper?
Concentrated acid has no ability of reacting with any metal. Yeah.
Yes, clear.
Concentrated acids, if you put them, they will just be there, just like somebody who is in this group and is dormant. Yeah, that's the behavior of concentrated acids. So you must be very active. So I will pour water on you so that you react. Is it clear?
Yes.
Okay. So we are forming this. Water is in which state? Is it a gas or a liquid?
Liquid.
Liquid. And then carbon dioxide?
Gas.
Gas. So our problem is to balance. Look at what you have here from this side of the equation, the right-hand side of the equation and the left-hand side of the equation. How many coppers are here? Only one. How many are this side? One. Copper is finished. Go to carbonates. How many carbonates are there?
3.
Okay, let's look at carbon alone. Carbon is 1.
1.
This side also we have what?
1.
1. Let's look at oxygens. These are how many? 3 oxygens. How many are this side? We have 2 plus
3.
1 to make 3.
3.
Now, let's look at hydrogen and the chloride. How many hydrogens are this side? How many hydrogens are this side?
1.
We have 1. How many are this side?
2.
2. So there is an imbalance there. How many chlorides are here?
1.
Yes.
How many are this side?
1.
2.
So what is missing?
2.
Putting a 2 on the
2.
hydrogen chloride.
No, on the hydrochloric acid.
Hydrochloric acid, sorry.
That is what you do when you're balancing. Now, there are people who are used to the senior 2 work of writing copper. This side we have 1. Copper, this side we have 1. This is when you are practicing. But in an exam, this is wasting time. You do what I'm doing, just start counting. Copper is 1, copper is 1, finished. Carbonate is 1, carbonate is 1, finished. Oxygens, we have this. As long as you know that when a carbonate reacts with any acid, the end product is water, a gas, and a salt. That's what you do. If you write a wrong equation, like somebody would say that we here write copper chloride as this, copper chloride, then you will find yourself here having 1 chloride, 2 hydrogens. If you try to balance, you get 2 hydrogens, 2 chlorides. Where would you put the 2? You will balance the equation until when you get tired and you give up. Say, chemistry. Which word do you use that chemistry is what?
Difficult.
It's very hard. I will not do it because even the judges did not do it. Who am I to struggle? They always say you have to make a difference where you are if you are to live in a society. Make a difference in who you are. And that's the way you can achieve success. Do what other people are not doing. If you all combine and say we all must do history, then make sure you do other things that people did do. Okay? So that is what we have there. So that is our statement here. Acids react with that to produce, if it is a carbonate, the end product is carbon dioxide gas. Okay? So even this sulfuric acid is a hydrogen carbonate. What you get is a salt of sodium sulfate, water, and carbon dioxide. The rest is balancing the equation. Let's look at this sulfuric acid added to sodium hydrogen carbonate. You get this is a solid, this is aqueous, this is sodium sulfate. Sodium has a valence 1. The sulfate has a valence 2. So when they react, the 2 goes on the sodium. So sodium sulfate plus water plus carbon dioxide. What comes is balancing. Here we have 2 hydrogens. Here we have 2. That one is okay. The sulfate, we have 1. That one is okay. Sodium, we have 2 here. Now, hydrogens are 3. Take note of that. Hydrogens are now 3. Here we have 2. So meaning, let's start with sodium. Sodium is 2. Here we have 1. Then carbonates, we have carbon 2. So we start with balancing. Sodiums, there are 2 here. Then here there are 2. So we have 2 hydrogens plus 2 to make 4 this side. Here we have only 2. So what you do, you balance them up also to make 4. This one's 2 plus 2 to get 4. Now what is left is the carbon and oxygen. How many carbons are here? There are 2 carbons. So here we have only 1. You make sure that there are 2. By the time you finish balancing the carbons, the oxygen should have balanced also. Let's try and check. Here we have 4 oxygens plus, this is 2 times 3 is 6. 6 plus 4 is 10. Check this side. We have 4 oxygens plus mine or someone. Because I think mine is
Good.
okay. Good. So here we have oxygens. We have 4 plus, these are 2. We have 4 plus 2 plus, how many are these? Oxygens, they are 4. If you add up, they give us 10, meaning oxygens have balanced, and our equation is fully balanced.
Just remember that your son.
Somebody who was talking of balancing, are you getting some information now?
Yes.
Okay. So make sure you get more and you practice. If you don't have, there is a paper we used to use those days when we were starting. I don't know if I have a copy. If I have a copy here, I would have showed you that this is our paper we started with. This is something close to that. Is it clear on your side?
This teacher.
Good.
Yes.
So this is valence 1, this is valence 2, valence 3. There are only 2 in valence 3. There are many in 2. There are also many in 1. Those are cations or positive ions. Then we also have the radicals now, the negative ions. An example is hydroxide. Whatever is OH, all of these O and H have valence 1. The nitrate is also there. NO3, which is negative. The whole of it has negative 1. So if they tell you to write a nitrate and you write some other thing, then it's a wrong thing you are doing. So those ones of valence 1 are here. We have a nitrite, we have a hydrogen carbonate, we have hydrogen sulfite, hydrogen sulfate, a chloride, a bromide. So if bromine reacts, bromine gas, the one you are seeing here, bromine, if they talk about bromine, it is Br2, the formula is Br2. So if they ask for a bromide somewhere, Bromine reacts to form bromides. So a bromide ion is here, BRMDIE, ion. Br and it has -1, but if they write bromine, hydrogen, nitrogen, all of them, their formulas are here. All gases exist as the atomic molecules. They are two, they are never one. So if you don't have this, I think I should do something. I post it there in the group so that you download and use it. Isn't it a better option?
Yes.
Okay. So I'm going to do that. So then there are some compounds this side, you try and form them at your own time. Then there are some equations here, you try and balance. So I will give you that later. So let's go back this side and check what you have not seen yet. Preparation of acids, you can prepare them from the acid anhydrides. Unacid hydrides, these are oxides of nonmetals that when dissolved in water gives us the acidic solution. Acid anhydrides are oxides of nonmetals. Oxides of nonmetals include sulfur dioxide. This is a nonmetal, this is a nonmetal. Those are oxides of nonmetals. Including carbon dioxide is an oxide of a nonmetal. When you dissolve it in water, it gives which acid? Carbon dioxide.
Carbonic acid.
Carbonic acid. So those are acid anhydrides. Okay? So that is the way you prepare acids. Maybe you get, this is an example of which reaction? They are saying a sodium chloride, a salt is reacting with sulfuric acid to give us this. This is by displacing a weaker acid or more volatile from its salt by a stronger acid. An example is displacing a salt like this one. You want the chloride from this. Sodium is more reactive than this. It will form sodium sulfate and the hydrochloric acid here. This one will be in a aqueous state. Then by precipitating an insoluble sulfide, this one will be forming a weaker acid. Now, like this one is lead ethanoate, which will give you ethanoic acid from here. Because of this, lead takes the sulfide from the hydrogen, and then this hydrogen combines with this to form ethanoic acid. Then you come